For this YouTube video, the topic I chose was from chapter 14 about brain damage and how damage to specific parts of the brain can cause problems in speech. The article I found was damage to the anterior arcuate facialis, AF for short, predicts non-fluent speech production and aphasia. And this article is by Julius Fredrickson and Paul Fillmore. Now, brain damage to certain areas of the brain can increase chances of non-fluent aphasia, which is the lost ability to understand or express speech caused by brain damage. This study was done to provide a clearer picture of cortical damage and aphasia by examining brain damage that negatively influence speech fluency in patients with aphasia. So basically, they just wanted to look at people who suffer from aphasia, look at their brain and see the similarities and see if the similarities come from the AF. Now, the AF is a bundle of nerve fibers that connect the temporal lobe and parietal lobe to the brain of the prefrontal lobe. And this is believed to be the instrument in determining one's ability to speak and write. The researchers examined 64 patients that suffered from a left hemisphere stroke, and they were from the aphasia lab in the University of South Carolina. Each patient was tested by a speech-language pathologist, and the behavioral testing consists of the Western Aphasia Boundary Speech Fluency Scale, and that is to know the degree of the type of dysphagia that each patient had. And they were grouped within 5 categories of aphasia. The first category was anomic aphasia, which 25 of the 64 patients had, and that's nominal. Anomic aphasia is nominal aphasia, and that's the ability to name objects, to even see or write or speak the object or even recognize it. 20 suffer from Broca's aphasia, that's motor aphasia, in which expression by speech or writings are severely impacted. 7 suffer from conduction aphasia, and patients have difficulties repeating a sentence that they just heard. 6 suffer from global aphasia, and that's the loss of ability to even communicate. And then the last 6 suffer from Wernicke's aphasia, and that's a receptive aphasia, and it impacts language comprehension and meaningful language. And then after this, all the patients were given an MRI, and the brain was scanned to look at the similarities and the damages to the brain. And they found that the lesion overlap was found in the anterior superior portion of the insula, which is a region of the brain deep in the cerebral cortex. And that's where 45 patients had incurred damage. They also found that the anterior segment of the left AF is a predictor and is a strong factor of impaired speech fluency in aphasia patients, even when motor speech, lexical processing, and executive functioning are included as cofactors. So basically, just any damage to those areas of the brain cause non-fluent aphasic speech. So when these areas in the brain are not damaged, you have fluent speech. And that's all.